Okay, so now the next question is, how do we generate a linear system? AU equal B. So U will be the vector of all the unknown values, unknown coefficients. So U11, U21, and so on up to U53. Okay, so we do it like as the previous question, but we have to do it like for each unknown. So you see, now we start with U11. So we have 4 U11, and then remember, so you have to minus the 4 neighbors. So here, because you have this one is unknown neighbor, so minus U12 and minus U21. Yeah, and because here we have 2 points on the boundary, and they are having the value for 20 here, 20 here. So 20 plus 20 is 40, then minus h square f11, yeah. And then for the second one, so you have 4 U21, and now you have to minus the 3 neighbors. So minus this neighbor U11, then minus U22, and minus U31, and then this one has the value 20, yeah, and minus h square f21, and then the next one will be U31, so 4 U31, yeah, and then you have the 4 neighbors, so sorry, you have 3 unknown neighbors, so U21, U41, U32, yeah, and then equal 20 minus h square f31, and then you have U41, so 4 U41 minus so U41 you have 3 unknown neighbors, so U31 minus U51 minus U42 equal 20, yeah, because this is 20 minus s square f41, and then U51, so for U51, so here you have 2 unknown neighbors, yeah, so minus U41 minus U52 here, yeah, and then equal, so 20 here, 20 here, so 40 minus s square f51, okay, and now you have to do the same for, you know, U21, so you have 4 U12 minus the 3 neighbors, yeah, so you have U11 minus U22 minus U13, okay, and because here we have this one is 20 minus s square f21, and then U22, so minus, for U22 minus, so this one all of them are unknown, so 1, 2, 3, 2, 2, 1, 2, 3, and you have on the right just h square f22, okay, and we got 3, 2 already, so we got 3, 2, so for U32 minus U22 minus U31 minus U42 minus U33 equal minus s square f32, okay, and then here we have so at 42, yeah, so we have U42 minus U32 minus U52 minus U41 minus U43 equal minus h square f42, okay, and then so on. So we have U So we have U52, so U52 minus U42 minus U51 minus U53. And here, because we know the value here, so it's just equal 20 minus h squared F52, okay? And then after that, we have U13, so 13, then minus, so now 13, see now you have U12, U23, and because those two values are known, so it's become 40 minus h squared F13, yeah? And for U23, so you have 4U23 minus U13 minus U33 minus U22, and this one is 20, so you know 20 minus h squared F23, okay? And then you have U33, so 4U33 minus U23 minus U43 minus U32 equal 20 minus h squared F33, okay? And now for the remaining two equations, so we have 4U43 minus U33 minus U53, and so U43 here, yeah, so 33 here, 53, and minus U42, yeah, and because this one is known, so you got 20 minus h squared F42, and then the last equation is 4U53, and you have U43 minus U52, and because you know the value here, 20 is 20, so become 40 minus h squared F53. So how many equations do we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yeah? So how do we rearrange this one into a linear system? Okay, so now we have 15 equations. So we just need to put it into a nice linear system. Then MATLAB can solve it. And you see that all the U11 up to U53 are unknown. So we put it into a big unknown vectors, you know, like this. So U11, yeah, then U21, U31, U41, U51. So this will be your unknown vectors, okay? And the right hand side will be, you know, I mean the right hand side here from the first equation. So 40 minus h squared F11, then 20 minus h squared F21, and then 20 minus h squared F31, and so on until the last one. The last one will be 40 minus h squared F53. Yeah, so this one will be the right hand side. And then the matrix. So the matrix will be a 15 by 15 matrix. Yeah, because we have 15 unknowns. Yeah. Okay. Okay, so now we have 15 equations. Yeah. So now we put the unknowns in the column vectors. So U11, 2, 1, 3, 1, 4, 1, 5, 1, then 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. Okay, so how do we write out the matrix? So the matrix, so now, so 4 U11, so 4 U11, so you put number 4 here. So minus U12, so minus U12, so here. So we have to write, so 1, 2, 3, 4, 5, and 6, yeah. So 1, 2, 3, 4, 5, yeah. 1, 2, 3, 4. So 1, 2, 3, 4, 5, and the sixth position. So 1, 2, 3, 4, 5. So this one you put in -1, yeah. And then you have minus U21. So minus U21 is right here. You put a -1. Okay. So we have 0 here. So there is nothing here, yeah. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, yeah. And then the rest are 0 because there's no other, yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, okay. And now the next one is U21. So U21 here, so U21, so we start with 4 here, yeah, at this entries, yeah, and then minus U11, so U11 is right here, so have to be a -1 here, okay, and then minus U22, so U22 is right here, yeah, so you have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, so you put -1 here, yeah. So, and then minus U31, so minus U31, 1, 2, 3, so 1, 2, 3, so -1 here, yeah. And then the rest is just equal 0. Okay, and then U31, so U31, so you have U31 here is 4. Okay, and then minus U21, so U21 is here, so -1 here, and minus U41, so U41 is here, so U41 is 1, 2, 3, 4, 1, 2, 3, 4, yeah, so 1, 2, 3, 4, so -1 here, yeah, and minus 3, 2, so -3, 2, 1, 2, 3, 4, 5, 6, 7, 8, yeah, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, so -1 here. So the rest is just equal 0. Okay, so we do one more thing and you see the pattern. So one more rows and you see the pattern. So 4, 1. So where is 4, 1? So 4, 1 is here. So 4, 1. So you see 4 is here. So it's a diagonal. Yeah. And where is 3, 1? So 3, 1 is here. So 1, 2, 3. 1, 2, 3. So you see the pattern here. And -5, 1, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, yeah, and then 4, 2, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, so -1 here. So the rest just equals 0, yeah. So you see the diagonal is always equal 4, yeah? And you have -1 and then -1 on the left and on the right of 4, yeah? And then you have -1 in the fifth, well, 1, 2, 3, 4, 5, and you have -1. So 1, 2, 3, 4, 5, you have -1. So 1, 2, 3, 4, 5, you have -1. 1, 2, 3, 4, 5, you have -1. You see? So you see the pattern. So now you have similar here. So you have 0. Well, let we check one more time. Yeah. So the fifth equation, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So 4 here. yeah, so for U51 and minus U41, so minus U41, so 1, 2, 3, 4, 1, 2, 3, 4, so you have minus 1 here, yeah, and then minus U52, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see? Now the pattern look like, you know, you have minus 1 for minus 1, but here there's no minus 1. Yeah, because we hit the boundary on the right. Yeah, so we have to be a bit careful. So now the rest is just equal 0. Okay? So even the pattern, but it has some structure. Yeah. So now look at the next row. So row 6, 1, 2, 3, 4, 5. So equation number 6, 1, 2, 3, 4, 5, 6. Okay, so you have 4 U12. So U12, 1, 2, 3, 4, 5, 6. Yeah, so the 6th row. So 1, 2, 3, 4, 5, 6. So you have 4 here. Okay, and then minus U11. Yeah, so minus 1. Okay, so now the pattern is different. So you see the pattern stop here. Yeah, so 1, 2, 3, 4, 5, because each row on the grid we have only 5. Yeah, so we have 1, 2, 3, 4, 5. So actually there's a split here. Okay, and then 1, 2, 3, 4, 5. So you see, so this one, so this block look like minus identity. This one look like 0 matrix. And this one, you know, I mean the first and the last one is only 2 entries, but the middle one has 3 entries, minus 1, 4, minus 1. Okay, and now we do the second blocks. So we have this equation, yeah, minus 1, minus U11 is here, yeah, and then minus U22. So where is 22? So 22 is right here, so it's right here, yeah. And then minus 1, 3. So minus 1, 3. So minus 1, 3. So minus 1, 3 is right here, yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so then the rest is just equal 0. 1, 2, 3, 4, 5. Okay, and now the next one will be U22. So U22 is right here. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 4 is here, yeah. And then minus 1, 2. So minus U12. So 1, 2 is right here. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So it will be minus 1 here. Okay. And then 3, 2. So 3, 2 is right here. So minus 1 here. Yeah. And then 2, 1. 2, 1 is right here. Yeah. And 2, 3. So 2, 3. 2, 3 here, yeah. So how many entries? So 1, 2, 3. So 1, 2, 3, so it will be here. So the rest is just equal 0. Okay. So you see now what is the next one? So this one is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So this one, equation 4, 3, 2. So 4, 3, 2 is right here. So 4, yeah. Then 2, 2. So where is 2, 2? 2, 2 is right here. So minus 1, yeah. Oh, sorry, 2, 2 is 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. So minus 1 is here, yeah. And you see the pattern. Just this one should be minus 1, yeah. And then minus 1 here, and minus 1 here. Okay. So the pattern extends to. So this one will be 0, 0, 0. 0 here, 0 here. 0, 0. So 0 here, yeah. And then the next one will be U42. So U42 will be here. So see this matrix look like minus identity, yeah. Minus identity, yeah. And this one look like the pattern exactly like here. 4, minus 1. Minus 1, 4, minus 1, and then 0 here, and 0 here, okay? And you see the pattern will repeat, but this matrix move down here, and this become minus identity. This is a minus identity, this is 0. Okay, so let we check the next equation. So the next equation will be, so 8, the ninth one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4, 2. So 4, 2 is here, yeah. And then minus U32. So minus U32 is here, yeah. And then minus U52. So minus U52 is here. Okay. And then minus U41. So minus U41 is here, yeah. Then minus U43. So minus U43 is here. Okay, and then the rest just equals 0. Okay, so now to be careful, we double check what is this row. So this row will correspond to this 10th equation, yeah. So we got 4, 5, 2. So 4, 5, 2 is right here. Okay, so 4, 5, 2 is right here. Then minus 4, 2, U42, so minus 1 is here. Then minus U51, so minus U51, so here, yeah. So it will be minus 1 here. Then minus U53, so minus U53, so the last one. So you see, so the last row, okay, it's not the same as this one, but repeat this pattern in the previous 5 rows. You see this matrix, yeah, this green matrix move down to here. Okay, the same matrix, and this is a minus identity. This is a minus identity. Okay, and now what is the last one? So the last one, you can predict that this matrix get moved down to here. Okay, and then you know this block will be a minus identity, and this is equal 0. Okay, so now you can check but let me write down. So I just make a prediction that this one should be like 4 minus 1 0 0 0 and minus 1 4 minus 1 0 0, then minus 1 4 minus 1 0, and this one will be 4 minus 1 minus 1 0 0. This one will be 4. Okay, so the last, so this matrix B got moved down here. Okay, and you can check that this one will be minus 1 0 0 0 0, minus 1 0 0 0, minus 1 0 0, minus 1 0, and minus 1. So just identity. Sorry, minus identity, yeah. And this one just zero matrix. Okay, see, from the 15 equation, so we come up with a matrix equation like this. So this one is the matrix A. Okay, and this is your unknown vector U, and the right hand side just equal B. And you see the matrix A has this structure. It has A equal, like 9 blocks, yeah. And the one in the diagonal is a B matrix. Okay, and this one is minus identity. And this is a zero matrix, and this is a minus identity, minus identity, so minus identity, and this is a zero matrix. So the matrix symmetric, yeah, okay, and it's positively definite, so it's symmetric and positively definite. And we can use Cholesky factorization because positive definite. And the matrix B is given like this. Yeah, so the matrix B is given as 4 minus 1 0 0 0 and minus 1 4 minus 1 0 0 0 minus 1 4 minus 1 0 0 0 minus 1 4 minus 1, and the last one will be 0 0 0 minus 1 4. So it's a 5 by 5 matrix. And why is 5 by 5? Because remember in the grid we have 5 unknowns in each row, and that's why this one is 5 by 5 matrix. Okay, and the coefficient 4 minus 1 minus 1 come from the discretized equation, and some people call this a stencil. Okay, so that is how you discretize the Poisson equation using finite difference, and then you come up with a linear system, and we can solve this linear system to get a solution at the grid points of the Poisson equations.